Today, we're talking about a massive change in the global auto industry. It's all about a new, unified rulebook that helps predict and, more importantly, prevent failures before a car even gets built. It's called the AIAG VDA FMEA standard, and honestly, it is a much bigger deal than it sounds.
But let's just start with this fundamental question. How in the world do you stop a problem that you can't even see yet? In an industry where safety is absolutely everything, this isn't some late-night philosophical question. It's a multi-billion-dollar engineering challenge.
All right, let's get into it. To really get why this new standard is such a game changer, you have to understand the problem it was designed to solve. See, before 2019, the global automotive world was basically speaking two completely different languages when it came to quality. Now, the tool everyone uses for this is called an FMEA. That's Failure, Mode, and Effects Analysis. The whole idea actually came from the aerospace industry, way back in the 1960s. It's really just a structured, systematic way for engineers to ask, okay, what could possibly go wrong here, and then answer that question before it's too late.
This right here is the perfect analogy for the chaos that was going on. Just imagine two teams of engineers trying to build the exact same car. One team is using millimeters and grams, while the other is using inches and ounces. It's a recipe for disaster, right? Well, that's pretty much what was happening with risk analysis. It was confusing, it was inefficient, and it created so much unnecessary work.
So on one side of the Atlantic, you had the AIAG standard, used by the big North American players like GM, Ford, and Chrysler. And on the other side, you had the VDA standard from the powerful German auto industry. Now think about a supplier who makes parts for both Volkswagen and Ford. They had to do two entirely different sets of risk analysis for what was basically the same component. It was causing these huge headaches all across the global supply chain.
Yeah, in a globally connected industry like this, that just couldn't last. So the two giants finally came together to create one common language for quality and safety. Let's take a look at how they actually pulled it off.
So after FMA jumped from aerospace to automotive, AIAG was formed back in the early 80s to streamline things for North America. For decades, their standard and the German VDA standard just kind of grew up side by side. But the real breakthrough, the moment everything changed, was in June 2019 when they finally published a single, harmonized handbook for everyone.
And the goal here wasn't just to pick one standard and ditch the other. No, the whole point was to take the best ideas from both approaches, the best of both worlds, and build a single, much stronger framework that everybody could use. We're talking about better communication, consistent standards, and ultimately safer, more reliable cars for all of us, no matter where they're built.
So what does this new unified rulebook actually look like in practice? Well, it's all built around a really clear, 7-step process that walks teams through the entire analysis from start to finish.
And you can see how logical the flow is. It all starts with planning and preparation. Then you move into structure and function analysis, which is basically figuring out what is this part and what's it supposed to do. It's only after that that you dig into failure and risk analysis, what could go wrong and just how bad would it be. And the final steps are optimization, where you fix the problems, and documentation, so the entire organization can learn from it.
And this quote right here, it gets to the absolute heart of the new philosophy. This whole 7-step process is designed to be proactive. It forces engineering teams to think about what could go wrong way earlier in the design phase, instead of just waiting for a problem to pop up and then scrambling to react to it. Now this is one of the most interesting changes. The old systems used something called a risk priority number, or RPN. You'd multiply 3 scores together to get a single number. But the problem is that one number could be really misleading. The new standard uses an action priority, or AP, matrix. It doesn't just spit out a number. Instead, it tells you, plain and simple, whether the priority for taking action is high, medium, or low. It's a much clearer roadmap for engineers on what they need to fix first.
So, how is all of this actually playing out in the real world? Well, as you can probably guess, a change this massive comes with some pretty big wins, but also some very real challenges.
The upsides are pretty much exactly what everyone was hoping for. When everyone is speaking the same quality language, collaboration just gets easier. Suppliers aren't wasting time and money duplicating their work, and you get this consistent standard for managing risk, whether you're in Detroit or Stuttgart. It just makes the whole global ecosystem run so much smoother.
And we're not just talking theory here. There's a real financial impact. The data shows that companies that really go all in on this and pair it with advanced analytics can see margin improvements of up to 30%, not to mention a potential 2 to 5% bump in long-term revenue.
This isn't just about being efficient. It's about avoiding those billion-dollar headlines that come with massive recalls.
But look, it's definitely not a simple switch. Modern cars are incredibly complex, packed with software and electronics, which makes analyzing risk that much harder. Then you've got the human element, cultural resistance from people who are just used to doing things the old way. There's a really steep learning curve, and the documentation required can take up a ton of time and resources.
This chart really sums it up perfectly. The short-term effort is high, there's no doubt about it. It takes a big investment in training, changing up processes, and getting everyone on board. But the long-term gain in efficiency, quality, and cost savings is designed to be so much bigger. It's a classic case of short-term pain for long-term gain.
So, where do we go from here? I mean, FMEA can't just stand still because the cars it's meant to protect are evolving at an absolutely breakneck pace. Well, the standard itself is built on this idea of continuous improvement, but it's also being pushed forward by all these external forces. As cars get loaded with more AI and incredibly complex software, the FMEA process itself has to evolve to handle totally new and unfamiliar kinds of risk. It's got to be a living document, not some static rulebook set in stone.
And that right there is really the bottom line. In an age of self-driving cars and constant connectivity, the way we make sure things are safe has to be just as advanced and forward-thinking as the technology itself. Being proactive about risk is more critical now than it has ever been.
Which really leaves us with this final thought. As the very definition of a car changes from a mechanical machine into, well, a complex software platform on wheels, how will our ability to predict and prevent failure have to evolve right alongside it?